Okay, good afternoon, everybody. Today we will continue and we will end our analysis of Cropwat. So if you remember, we saved our sessions. Let's see. Okay, Modena 2022. And we already had our measured ETO from the Modena station. So we put it in the algorithm. We also introduce rainfall. We also selected the crop. In this case, we selected alfalfa perennial, and we were discussing about soil. Based on our evaluation of the soil characteristics from the USDA soil map, we selected, because we don't have many options, we selected a medium soil type, a loamy, which has the following characteristic: 290 millimeters of water per meter. That's the available water, total available water between field capacity and wilting point, and infiltration rate. Maximum root depth. Maximum rooting depth is not of the plant, but the soil. We're saying is about 9 meters. And initial soil moisture depletion. What is indicated in this case? Maybe I should talk about. Okay. But is everybody up to this point? Did you save your project from last time?
I don't think I saved it at this point, so I put the information in, but.
Okay.
Probably did not find it. Yeah.
Okay. Do you want me to share my files? Okay, I can always share. But again, it's always important that you save. Yeah, so let me go to Canvas then. Canvas. Where is? Going to put it in announcements. Let me ask you, did you have any trouble running RefET for the Delta site and Logan site? You already are masters on it, right? That's good.
My Excel didn't like any data point. Excel kept crashing on me because it's too much data.
Really? Oh. If you may, what you had, hourly data or 15-minute data?
Look at it now, whichever one is actually.
Okay. Were you able to complete it?
Yeah, I got it.
Okay, good. Okay, desktop Cropwat example. Yes, I'm going to pass you the three. It only allows me to pass, submit. Okay. Okay, you should have it in Canvas. You can download all of them into a one folder, single folder. I'll wait for you. In the meantime, I'll be looking at plots.
Where did we get the soil data from? I remember we went to that website. Was there like a tab on there that like tells you?
Yes. Yeah, okay. So did you guys downloaded my files?
Yeah.
Is it opening?
Mhm.
Is it giving you what we did right now is the climate data, the rain data. All the rest can be filled up from the software. Okay, you got it?
It's loading.
Yeah, okay.
It's loading. No, it's not over here, but it's loading.
Okay.
Okay.
Works. So,
Loading. I'm opening. It's applying, but
Is it
close. Some. Exit. Right.
right there?
Open session. File. So, are you able to see this? Okay, you are not able to see. Click.
It wouldn't let me look in the session file, but if you when you hit file in Cropwat, if you go down to just open, not open session, you can open the climate and the rain individually.
Use. Nothing. Okay, go to. Oh, yours is empty? Again. All right,
I gave you 2 more files. Do yours open?
Yes.
You got both the climate and the.
Just use mine. So they.
Okay. Okay. So if you're having issues with Cropwat, Okay, I'm going to open a new window. I give you 3 files, right?
Yeah.
One is for ETO and the other is for, so if you go to, if you don't have anything, just go here in climate, go open and go to the files that I gave you. Where is my, here is the ETO. Then you go to rain, you go to open, navigate to the other file I gave you. And you got all the data. That should work. That should be better. Yes?
Just open. And it's asking you to download it again. Could you download it to your desktop? Files. Yeah, I have them. Download it again. Yeah, go to the Canvas page. This one? All of them. Okay. Or leave it there. You can leave. Okay, put it in the list. Okay. There we go. Do the same for rainfall. Okay, is everybody there? بصراحة إنها بس تدخل في حاجة كان بيعمل معايا يقول لي كده صح؟ أنا مش بيظهر أصلا. بس يوم أنت بتجيب في يوم أنا فاكر على السكول تقعد تسكول. هيشتغل يعني؟ والله اشتغل. So I will do climate, rain, and the crop.
So just climate, rain. I will show you how to open crop again.
Okay.
Okay. So if you have climate and then you got rain, okay. Now crop, how we do it? There is an open here. And here is all the coefficients that FAO 56 has in a store. So here we have alfalfa, beans, citrus, grapes. So, well, remember that these are crop coefficients and their value is, it's more focused or more oriented to planning, but less for managing, unless you have local crop coefficients. These are like general crop coefficients for across many climates, many regions, but every location has their own weather patterns, their own soil characteristics that influences your crop coefficients. So if we select alfalfa 1, we have these crop coefficients for our alfalfa. And we have the initial development, mid-season, late season. Here we see that the planting date is that date that is going to be related when the sowing happens, the putting the seed on the ground. In this case, it's saying the 14 or mid-March is the planting, but that's going to depend on the local practices. The more to the south you are, you don't have winter or harsh winter conditions. So you might be planting this 1st of January, or the crop is already there. But the higher the latitude, you have a more extended winter. So the starting day for the plant to need water delays in the calendar year towards March, April. So in this case, we are selecting our starting day, the March 14, or we can say March 1st. Okay, and here we have the stages of the crop. It says that the crop is going to start growing the first 10 days, then it's going to have an increasing biomass towards floration in 30 days. The mid-season is going to last 160 days, and the late season is going to be 35 days. Overall of 225 days in growth. Critical depletion is that level of reduction in the total amount of water that will affect the yield of the crop. Less than that, and the crop will suffer reduced yield. Critical depletion, crop height 0.7. For soils, we do the same. We click on soils, we got this tab with no information, we go to open, we go to FAO, and we initially indicated that it's a medium soil type. So it will fill it up for us. But we might have this information from soil analysis. And this is having these values from the area itself are important. So any soil analysis will have the information about the field capacity, permanent wilting point, the texture, infiltration rate. Who remembers how infiltration rate is calculated or measured?
By sensors on depths, certain depths.
Infiltration, not soil moisture.
The amount of water that I get in and the amount of water that the plant use, like the storage.
Yeah. Infiltration rate.
So they just like put a bucket on the ground, let the water drain out, and time how fast it goes in.
Yes. Yes, because for example, when you are using sprinklers and you are going to select a sprinkler, the sprinkler will have a flow rate, right? It will say 5 liters per hour or 10 liters per hour, 1 liter per hour, right? So that amount of water, if the soil isn't able to infiltrate the water like 1 liter per hour, then what happens is less water will infiltrate and the rest will be runoff. So what we want is our sprinkler to be the same or less than the infiltration rate of the soil. So we want the soil to be like a sponge for my sprinkler. The same for furrow irrigation. If we're flooding the place, we don't want the water to stay on top of the field. We want this to percolate through the soil profile. So we don't want to have an initial high flow rate. We want that initial flow rate entry to the field responding to the infiltration rate of the soil. And as you say, is called the Stu ring infiltrometer. Have you ever done this experiment? Who has done it?
I know.
No?
I didn't do it. I didn't know what.
Okay.
In a soils virtual lab.
Yeah. Well, so the idea is you have these two rings, okay? You will fill it up, both of them, with water, but on the one in the center, you will track how the water gets infiltrated in the soil, how fast, like let's say you fill up water in both of them.
So I fill one of the middle with water and see how much water will go out.
The idea is you fill the water on the outside ring first.
Okay.
Okay. Then you fill up water in the internal one. Okay. And you measure the height from the surface of the ground to the surface of the water. That's your time zero. You wait 5 minutes. Now you measure how much water it has descended on this ring. You wait another 5 minutes and you keep measuring. So, but when you plot time against depth, against volume, basically, because if you have depth and you have the area, you have the volume. Okay. So with those two, you will see that the infiltration rate initially is very fast until it flats down. Time, volume, time zero, time 1, time 2, time 3. In Cropwat, when it asks maximum rain infiltration rate, is asking for this value. This one. Okay, because these initial values are large, but the soil gets saturated. At that point, it only can let water pass at this speed. So this is the speed that goes for the sprinkler selection. So when irrigation, these companies that sell a sprinkler system or drip systems, they go to the field and do, in some cases, they do this test. And it has been quite traditional. There is an improvement on this model. The two-ring scheme Let me see. No, I don't want this one. Is my internet very slow or? Because I don't get it. So there have been an improvement on the technology itself, that now that Turing technology is controlled by an Arduino computer. So your job in the field is just to monitor the water here. It start beeping, you add more water. But here is collecting all the data about the water percolating. This is called the Saturo sensor. It's a $5,000 piece of equipment. But instead of you with your ruler measuring the infiltration, it does it for you. Okay, so the initial soil moisture depletion, as mentioned here, depletion means how empty is the soil. From that total available water, how much is in the soil? When you say zero here, it means that the soil is at field capacity, that you are starting the irrigation season the entire year at field capacity. And this might be true, it might be not true. How do we know that? Well, if we have soil moisture sensors in the field, we can estimate the field capacity, or we can see if our soil is at field capacity or not. Okay? So this is the soil component. We selected our crop. Here, we already see the crop water requirements. Let me see here. So we put the starting irrigation day as the 1st of March. Here in this table, we have the different growing stages: initial, development, mid. The crop coefficient itself calculated for these different decade. What decade means here in this column? Here is meaning every 10 days. So in a month, there are only 3 decades, every 30 days. Okay? So this is not a date, it's not October 2nd. This is October, the 2nd decade, from the 11th to the 20th day. Okay? So for each of them, the software has calculated the crop coefficient. It has the estimated crop water use per day and the total for the decade. We have the effective rainfall based on the information we provided. And the last column is the irrigation requirement. So can we plot this? So what you're looking at, this is how much water, after accounting for rainfall, this alfalfa crop is going to need per every 10 days for the season. So it did the water balance for us.
What? What does the within days?
How much irrigation is needed every 10 days. Here we need to apply 10 millimeters, the second every 15 millimeters, the third day 30 millimeters.
How we get this required system?
When you go to crop water requirements, you get this table,
okay,
and you click on chart. Okay, and then we see that In this period, we need less water between 7 and 8, and that's because we have rainfall occurring that day, which is compensating the water needs of the crop. Now, if we go to schedule, and if we want to, we have two ways to estimate here the water needs. This is the irrigation schedule. According to the information we provided, alfalfa, this alfalfa, as we set it up, requires 6 irrigation events. The 28th of April, the 27th of May, the 20th of June, July. So here is telling me this is the irrigation requirements every 10 days in this chart, but it's not saying it is time to irrigate. We need to let these values accumulate so I can go from field capacity, from the field capacity condition, it will decline to the threshold limit that we established, which was here, 55%. We said that from the total available water, we said that we can let it go up to 55% of the total available water. And at that moment, we will irrigate. So we might want to see this in a chart. So these are days after planting. Okay? So this is the 5th of March, 10th of March, so on. So, but these are the, so from the first day, we see that it is the irrigation requirement accumulate, and it says that our first irrigation will happen almost 2 months later. Then, as the crop starts developing, why 2 months? Because the soil was at field capacity when we started our analysis, okay? And the plant is recently planted, so the root depth is shallow, so, and the crop is small, so it's up to 2 months, okay? But now that the crop is developing the biomass, we need to irrigate in a month. The next one in about 20, 25 days, 25 days. And in this part, it's like no, yeah. And here is our,
This is the attrition rate.
yeah, this
That
is our
melting point, I think, and says 0.55%.
So this is the permanent wilting point here.
We can.
This is our threshold. This is our 55%.
True.
So it's accumulated. So it's doing for us the water balance component. Okay. But what happens if, let me see where we can have options. Options, schedule, options. Okay, if we go to a schedule, okay, it opened this chart. What the field efficiency we're considering? So timing, it says irrigate when the field reaches critical depletion, means that from the total available water, we're at 55% of the total. The application of how much we're going to irrigate, it says refill the soil to field capacity, which is traditional. And we're saying that our field, that means that the way we irrigate and the way we distribute water, the efficiency is 70%. What type of irrigation technology is 70%?
Surface. For surface, it's 60.
Yeah.
surface, 60.
I think it's
Drip is more like 90.
drip. So what happens if we change this? So click on options. Okay. Here at the bottom, you can change the efficiency. Okay, but before doing that, let's open a Word document. We're going to do screen captures to compare. So we have this one, and I'm going to capture this. Let me expand this like this. Okay, I have our first scenario capture in a screenshot. Here, what I want to compare with you is these values. Total gross irrigation, total net irrigation, actual water used by crop, deficiency irrigation, we don't have that. This is the rainfall we have. Okay, so these values is not going to change. This moist deficit at harvest, this might be the soil moisture left over in soil. Actual irrigation required. So what I want to see with you is how these values change with technology. So let's go to Cropwat. Let's click on schedule. Let's click on options. And now let's put a drip irrigation system. Let's put 90. Okay. Let's look at our figure. Okay. The irrigation pattern has changed a bit. Let's see the schedule. And let's do a screen capture from this.
From 70 to
90. So let's start doing our comparison. So when we use a system that is 70% efficient, we're having 1,400 millimeters of water needed. That's the gross application. When we increase the field efficiency to 90, we have saved, or we're in 1,100 millimeters per water. We save 200 millimeters per water. Let's see, total net irrigation is on 978. 978. So in both cases, we provided the plant the water that it needed.
because the plant didn't change.
The plant never changed, but what we saved was because of the change of technology. The question for you, okay? And this is a question that we cannot answer easily. So on scenario 1, okay, the gross water was approximately, okay?
And
Scenario 2,
11 something.
per season. So you have a delta.
300.
Okay. 300 millimeters per season. So we're going from a sprinkler to drip. is this change in water or saving in water important? The question is it cost effective?
We'll see like the amount of money I pay for this water and the amount of money I will pay for the new system.
There you go. Okay. Having a sprinkler system costs X amount of money. Having drip, X. Okay. This is going to be larger than this one. Plus human time. Human time. Human time. They are different in both cases. This is simpler. We see many alfalfa producers here use sprinkler systems, but very few, almost nobody, uses drip irrigation. Despite has been tested to be possible to implement a drip irrigation systems in already existing sprinkler system. So to put it this way, is the only part we have. Okay. Delta of water the change in saving of water versus the change in cost of having the system. This is the question that is really hard to answer. Because, for example, in Utah, we live in drought, we live in an area. So there might be farmers that use surface irrigation, okay? They could move, and let's run on a scenario. A scenario 0, efficiency 50. Change it to 50.
It would be like almost to 20.
Okay. Let's do your capture. Okay. A scenario 0, surface irrigation, flooding, is 2,000. Okay. So this software, keeping everything constant, like the crop, like the crop and the planting day and such, is allowing us to see how much water need these 3 irrigation systems: flood irrigation, surface, the sprinkler, and drip irrigation. The question is it convenient for a farmer? Is it cost effective? Changes in water saving over changes in dollar amount. From here to here or from here to here. So for a surface irrigation field, the 1,600 millimeters here, it's a huge saving already. So it becomes very attractive, right? But from here to here is 300, but the system complexity is much higher. We need to do the flushing of the laterals, repair the lateral when they got hurt or chewed by animals. So there is much labor on the drip irrigation system than in the sprinkler. The sprinkler it could be these aluminum pipes, and there could be these rolling wheels or these center pivots that require very little maintenance. They require some work, but is not as intensive as the drip irrigation. So in terms of time, in terms of money, for many traditional irrigators, this jump is very attractive because it's going to cost money, yes, but the amount of water that you're saving, it's enough. To give you a story, how many of you know Scipio? Hey, Scipio is a town that is on your way from Provo to Fillmore. It's a tiny town that is basically a rest stop. You go and buy chips or go to the bathroom there, okay? But there is agriculture there. And it has its own reservoir, okay? Doesn't depend on any river or groundwater. It has its own, it's surrounded by mountains that provide water to reservoirs. So they're independent in that way. Traditionally, they were here, flood irrigating their farms. They were able to get per year 2 cuts of alfalfa. Okay, because being closed by mountains make the weather cold. Okay, and also the efficiencies that they had because of surface irrigation was low. Then the US Bureau of Reclamation came with an idea. We're going to pipe from the reservoir to to a corner of your field. Okay, we're going to pipe all the water. We're not going to have canals anymore. And you, the producer, will ask for a loan to implement a sprinkler system. Many of them did it. And they were able to save enough water to get an extra cut of alfalfa. So same amount of water every year, but now they have an additional cut. So in this equation, what we're not looking is, this is the cost of investment, but also there is like a plus for extra yield. Because now you're seeing, like, we're in 2000, we have 600 millimeters of water saved. That allows me to irrigate one more cut. That's enough. So with that, I got an extra plus here with the same amount of water. So I'm still using the 2000, but I got more money. So this cost from here to here, which costs money, start getting offset by this extra harvest. So Cropwat helped us to do these exercises, right? Allow us, if we are talking with a producer of cotton, if we're talking with a producer of tomatoes or rice in Egypt, and what else? Wheat. We can enter the values as we did it in these 3 sessions. We enter the rainfall information. We check those crop coefficients that FAO is giving us, because typically there are local studies that says, don't use FAO, use these crop coefficients, okay? You enter that and you can simulate the scenarios, okay? You can simulate the scenarios that you compare current conditions, technology 1, technology 2. This part of the dollar amount is good to do it with economist, that an agricultural economist, because they will keep track of the fixed costs, the variable costs that happen in a ranch or a farm, equipment, labor cost. That happens in this scenario and this scenario. Okay, what else can we do here? What else can we do across? What other questions we have for Cropwat? Let's go to options. Yes, we can do that. Let's go to rainfall. Okay. And let's click on options. Okay. In the Cropwat options, we can specify a fixed percentage. If I got 2 inches of water, 80% will go into the soil. If I have 1 inch of water, it will go 80%. Or I can use, so far we have been using the USDA soil conservation, but we can tell it, don't use it. And this is, now we're dealing with ideas related to climate change. If you select the rainfall not considered in calculations, we're saying that at some point, there won't be any rainfall that help us, and we will depend completely on water from canals and pumps. Okay, let's do that. Let's change our efficiency to, okay, let's see at 50%. Let's see, Ray. Let me see, did it accept? Okay. 0, 0, total effective rainfall, 0. Okay. We got our crop, we got our soil. Okay, let's see our schedule.
What options you make?
Oh, just go to rain. Options. The bottom says rainfall not considered in irrigation calculations. So do we see any difference with our screenshot? This is at 50% capacity. This is still showing, maybe I need to close it.
Because like the option we were used didn't consider the rainfall. Like the USDA didn't consider the rainfall, I think.
No, what I needed to do is to close the schedule window. Why I still have effective rainfall? I might need to close this one. Rainfall method 0. Okay, rainfall 0. Okay, schedule. This is still showing this value. I don't know why. This should be 0. Do I need to save? Because I can see it here. Weird. Options. Irrigate, fill capacity. ATI depletion. Here, for some reason, is using. Maybe what I need is to save it. Save the project. Save session. Going to close it for a second. Let's see, rainfall. Okay, here, change it. Okay.
Schedule.
Yep, let me see. Here is a 0. Scheduler is still there. I'm not sure why. I don't know why. I'll need to check on that, but we're getting water in the rainfall column here. Okay. All right, so that option doesn't work in Cropwat. Okay, so what we have learned from Cropwat so far? It helps us manipulating the different systems, allow us to quickly obtain total amount of water needed based on the efficiency of our system, allow us to tailor the estimation of crop water needs with local information like soil type, weather data, and also the crop coefficients. While we're using the default values given by FAO, it's important to check with our local experts if they have different crop coefficients for the crop. In that way, this amount of water that we estimated are closer to our to the reality here.
So what will we talk next with history?
We will talk about introduction to Cropwat, no, to aquacrop. So aquacrop, so with this, we're doing water balance. Okay, with this software, it allows us to do water balance. Let me see what happens when you click print. Print console. Crop data are not okay. So something is off with my dry crop data. Here it is, here it is. Oh. Yeah, weird. Rain method none. What happens if I change it to fixed percentage?
I tried to change it, it's the same.
Because it's 175.
Same.
Total rainfall. So weird. Okay. So aquacrop help us to now with this software, we're estimating how much water, gross irrigation requirements are needed. If you multiply this by the number of alfalfa fields, and you do the same for barley and you multiply by the number of barley fields, you can sum them all and you get a total for the irrigation area, for the irrigation region. So with that amount of water, you can compare that with what is typically available in the reservoir and see if those matches. Or if what you have in the reservoir is not enough for the initial level of technology. Let's say everybody in the new delta does flat irrigation, okay? But you have alfalfa, barley, and rice. With Cropwat, you calculate for surface irrigation, you calculate the total amount of water. But the amount of water coming from the Nile is less that you need. What do you do?
Try to make another system like sprinkler.
You can jump here. Okay. The other is reduce the acreage. It's not a popular idea, but you can reduce the number of hectares being irrigated. So that's an idea that is happening here in Utah. When in drought, cities, for example, need water. Okay, because in cities, you cannot just shut off. You need to give water to the people that is living to the city. So the city might rent or buy the water from the farmer. That means that water won't go to the farm anymore. So, so that reduction in acreage can happen in that way. So with this software, we're able to calculate the total gross irrigation, the net irrigation. Not sure why this is not updating, but this should be 0 here because this value is not changing, and that should change. With AquaCrop is different. What we're going to do is we're going to look for a relationship between the water we apply and how much yield we have. Let's say for barley. Let's say for barley, you need this value for the season. Let's say severe drought hits everybody. Now that barley producer only has this amount of water. What should be the recommendation? Should he plant barley this year or not? So typically the barley producer uses 2,000 millimeters of water. But this year, because of the drought, he will only get 1,400. The question is, should the farmer plant barley?
It depends how much this amount of water will affect the crop production.
That's what AquaCrop answers. So in AquaCrop, you can enter this value, this shorter value, and see how the reduction on yield will occur. So we're connecting these trees of RFET, allow us to calculate the basic parameters for Cropwat. Cropwat help us evaluate different irrigation scenarios. Okay? And AquaCrop allow us to evaluate what's the performance of the yield production in the different scenarios. Right? So that is the component we're going to study on Thursday. Okay, so some of you have been watching the videos, but I think I'm going to request that everybody watch the videos after the seminar we will get. In the seminar, you will get an overview of AquaCrop.
It's like the videos explaining how it works and the principle of the laws, how to get manually sent in the
Yes. So we will be working for the rest of the sessions in this class how to set up AquaCrop and use our data into AquaCrop. First, we will use the internal data, and then by looking how they format the data, we will format our data from Modena to run it in AquaCrop. Okay? All right. Any questions about Cropwat? Well, I hope you enjoyed. This is a software that when I was a student, it was appearing, this software. Mm-hmm. But this is a software that is used in many countries because the information is scarce. Here, while everybody has tried to do a water balance, building a spreadsheet, okay? I think with Cropwat, we can speed up that process. Okay, and as we know how to set it up, then we can run different scenarios. Okay, that's it all for today. I hope you like it, and I'll see